This is problem number 9. We are given a deposit of 10 that's made today, a deposit of 20 that's made 15 years later. And we're told that during the first 10 years, we compound a discount rate quarterly, and we don't know what that discount rate is. And then during the last 20 years, we compound an interest rate semi-annually. We're told that that interest rate is 6%, and that the accumulated value after 30 years is 100, and we want to find this value of D that we're using to compound during the first 10 years. So let's draw out a timeline, get a better sense of exactly what's happening. At the beginning, year 0, we deposit 10. The end, year 30, we have 100 total. At year 15, in the middle, we deposit an additional 20. And then at year 10, we make a switch from using this quarterly discount rate to a semi-annual interest rate. So let's think it through before we write out an equation. This 10 is going to earn at this rate for 10 years, and then at this rate for 20 years. The 10 that we deposit is going to accumulate interest for the full 30-year period. The first 10 years at this discount rate, and the last 20 years at this interest rate. We don't stop accumulating interest here just because we switched to a different, or because we made a different deposit, an additional deposit. So the additional deposit here doesn't impact the accumulation on the initial deposit. So in the additional deposit, we are going to accumulate for 15 years at this interest rate here. So I think there's a wrinkle here. It's a really good problem to really get a sense on how accumulation works when you have multiple deposits. So here's the equation we can use. Deposit 10 and accumulate at our quarterly discount rate raised to the four compounds per year times 10 years times 1 plus going over to our semi-annual interest rate, which we know is 6%, compounded twice a year for an additional 20 years. And then we make the next deposit. And that deposit is going to also earn at our semi-annual interest rate, compounding twice a year, but for only 15. So let's simplify what we can, and I'll work it out in a few steps. You could probably go straight to your calculator at this point, because with this problem and many others, and really why I emphasize this timeline so much, it is writing out the initial equation that needs to have the most attention given to it. Once you're confident you've got the correct equation, the math is usually pretty easy. It's usually just algebra. So 0.06 divided by 2, this is really just going to be 1.03 raised to the 40. And this here will be 20 times 1.03 raised to the 30. And all of this is equal to 100. Right? We accumulate over the time period to get that total value. All right, let's simplify again. This is all one term. 10 times 1.03 raised to the 40 is 32.62 and some decimals. I'm only going to write down 2 decimals, but because our answer choices are so close together, as I actually compute, I'm going to use the full 8 decimal figure that the calculator creates. Times the term with our unknown, plus, again, we can put this straight into the calculator for 48.54 equals 100. Again, only writing 2 decimals, computing with all of them. So, 2 steps to isolate the term with the unknown. Subtract the 48.54 from both sides and then divide both sides by 32.62. So that leaves us with the unknown term here and is equal to 1.57738. Raising both sides to 1 over negative 40 because we want to cancel the exponent, right? So if we have an exponent of 40, the rule is to multiply the exponents. So 40 times 1 over negative 40 will simplify this exponent down to 1. So raising both sides to 1, the reciprocal of this exponent, gives us 1 minus our unknown over 4. And I guess I won't need parentheses from here on out. Using the calculator, we get 0.9887. Yeah, that's fine right there. A little bit of rounding. Subtract 1 from both sides, multiply both sides by negative 4, and we get our value for D. So correct answer is C. Be sure to use many decimal places. I think 5 will always get you the correct answer, but I just use what's produced in the calculator, which is all 8. Write out your timeline. Think about how much each deposit actually accumulates. This deposit of 10 has got to accumulate for a full 30 years, but those 30 years are split between 10 years with a discount rate and 20 years with the interest rate. And then the second deposit of $20 accumulates for 15 years at the interest rate as well. Once you've got a good timeline, you can write a good equation, and from there on out, it's just algebra.